Hi everybody, in today's video we're going to be talking about how to multiply matrices together, which is going to be a lot harder than the addition and subtraction was, a lot more difficult than just doing the scalar multiplication. Okay, this requires a bit more of a process. So let's first talk about the requirements that we have to have in order to actually multiply two matrices together. So the first requirement is that the number of columns in the first matrix must match the number of rows in the second matrix. So let's look at the example that we have down below. We have a 2 by 2 matrix, okay, 2 rows, 2 columns, being multiplied by another 2 by 2 matrix. Okay, these dimensions, the columns of the first matrix, have to match the rows in the second matrix in order for multiplication to be possible. The other important thing to know here is that when we have two matrices that can actually multiply together, they might not end in the same size of the two matrices that you started with. The dimensions of your new matrix are going to be given by the rows in your first matrix, by the columns in your second matrix. So in this case, we would end up with another 2 by 2 matrix, but that doesn't necessarily have to happen. Your new matrix could be of a different size. So let's talk a little bit more about the actual operations that we're doing here. Okay? If we know we're going to end with a 2 by 2 matrix, that means I need to get 4 elements. To get the element in the first row, first column, I'm going to take the first row and multiply it by the first column here. We're going to multiply A times E, and then we're going to add that with the product of B and G, which you can see over here in our new matrix. Then to get my second element, okay, first row, second column, we're going to take the first row again, but now we're going to multiply it with the second column. A times F plus B times H. And then we can repeat this process to create our second row. So let's hop over to an actual example with some numbers here so you can see how this works. So we're trying to find X, Y, okay, and we're given what those two matrices are. So let's check and see if we can actually multiply them together. So this is a 2 by 2. This is another 2 by 2. The columns here match the rows here, so we know that we can actually multiply. And the dimensions of my new matrix are going to be 2 by 2. So we need to find four elements here. So to find my first element, I'm going to take the row in the first matrix and multiply it with the column here. First column in my second matrix. We're going to do 6 times negative 5 to get negative 30. And we're going to add that with negative 3 times 3. Okay. Now I'm going to find the element in my first row, second column. So I'm going to use that first row in my first matrix here, but now I'm going to be using the second column in matrix Y to multiply. So now we're going to do 6 times negative 4, and we're going to add that with negative 3 times 3. So now we're ready to move to our bottom row, okay? To find the element in row 2, column 1, I'm going to use row 2 and column 1. So negative 10 times negative 5 is a positive 50, and I'm adding that with negative 2 times positive 3. Okay, now I want row 2, column 2, so I'm going to use row 2 and column 2. So now I'm doing negative 10 times negative 4 plus negative 2 times 3. And to get my final answer, I just have to do the addition that I set up here. Okay, negative 30 plus negative 9, negative 24 plus negative 9, 50 plus negative 6, 40 plus negative 6. And here's our new 2 by 2 matrix that we got as a result of this multiplication. Okay, so we have to check and make sure that multiplication is possible first. Once we've identified that, hey, we can actually multiply, you're going to want to look at the dimensions of your new matrix before you start actually multiplying so that you know the size your new matrix should be. So let's look at one more example here. Okay? We're doing G times H, and the order does matter. So G is a 2 by 3 matrix, and H is a 3 by 2 matrix. So we know that we can multiply because the columns in the first matrix match the rows in the second, and we know that the new dimensions are going to be a 2 by 2 matrix. But you're going to see that we have a little bit more work to do this time, because when I go to find my first element, there are 3 elements in my first row and 3 elements in my first column. So I'm going to have to do 1 times 2 plus 3 times negative 2 plus negative 5 times 1. So the addition of those numbers is going to give me my first element. And now, to get my element in the first row, second column, I'm going to use the first row and second column. So now I'm doing 1 times 3 plus 3 times negative 8 plus negative 5 times 7. And now I'm ready to move to my second row. So now, if I want to do row 2, column 1, I'm going to use row 2, column 1. So 4 times 2 is 8. Plus negative 2 times negative 2, plus 0 times 1. And then we can find our fourth and final element here. Okay, row 2, column 2, 4 times 3, plus negative 2 times negative 8, plus 0 times 7. So now, to get our actual matrix, we just have to add all of these numbers up. Okay? If we find the sum of these numbers, we're going to know what our new matrix is. So when we multiply G times H, the matrix we end up with, that 2 by 2 matrix that we end up with, is negative 9, negative 56, 12, and 28. So this is an example where we started with 2 different sized matrices, okay, a 2 by 3 and a 3 by 2. We were able to multiply them together, and the result is a matrix of a new size, which is 2 by 2. So this is a lot more complicated. It's going to take more time. It's going to take more practice, and we're going to do a lot of that in class coming up. So let me know if you guys have any questions. Hopefully it kind of makes sense. We will be talking about this quite a bit and having a lot of practice. So have a great rest of your day.